Good morning. This is a lecture in continuation to the previous lectures on solar energy harvesting. So, in the first, in the part as a part of Unit 3, we saw what is solar, the concept of solar energy harvesting. We also saw the concept of a solar cooker as well. So, in this slide, we will see the importance of solar water heater. So some of the prerequisite or the recapitulations to this lecture moving forward includes the energy sources, the role of solar energy in daily life, also the principle of solar driven technology appliances like solar cooker and solar cells. So the objectives of today's lecture moving forward will be all about on six criteria. Number one is solar water heaters. Number two is how do the solar water heaters work. Number three is storage tanks and solar collectors. Number four is selecting a solar water heater. Number five is installation and maintaining the system. And number six, which is the most important, where we will deal about the heat exchangers for the solar water heating system. So coming to the introduction to solar water heaters, so you can see in the image that the solar panels heat the water that is delivered to a storage tank, and this is the photo courtesy to the David Springer National Renewable Energy Laboratory. So solar water heaters, also called as solar domestic hot water systems, can be a cost-effective way to generate hot water for your home, and they can be used in any climate, and the fuel they use, that is sunshine, which is absolutely free. So a second objective of today's lecture was all on how do they work. So solar water heating systems include the storage tanks and solar collectors. So there are two types of solar water heating systems. One is called as active system, which will have circulating pumps and controls, and the other one is called as passive, in which they don't have the circulating pumps and controls. So there are in now talking about the active solar water heating system. So there are two kinds of active solar water heating systems. One is called as a direct circulation system, and the other one is called as indirect circulation systems. So in direct circulation system, the pumps will circulate the household water through the collectors and into the home. They work well in climates where it rarely freezes. But in indirect circulation system, the pumps will circulate a non-freezing heat transfer fluid through the collectors and a heat exchanger. So this heats the water that then flows into the home. They are popular in climates prone to freezing temperatures. So second one was the passive solar water heating system. So passive solar water heating systems are typically less expensive than the active solar water heating systems, but they are usually not as efficient. However, passive systems can be more reliable and may last longer. So in passive systems also we have got two basic types. One is called as integral collector storage passive system, and the other one is called as thermosiphon systems. In integral collector storage passive systems, as we know that they don't require any pumps and everything like active systems, so they work best in areas where temperatures rarely fall below freezing. They also work well in households with significant daytime and evening hot water needs. In thermosiphon systems, water will flow through the system when warm water rises as cooler water sinks. So water will flow through the system when warm water rises as cold water sinks. The collector must be installed below the storage tank so that warm water will rise into the tank. And these systems are very much reliable, but contractors must pay very careful attention to the roof design because of the heavy storage tank. They are usually more expensive also than your integral collector storage passive systems, and but they are reliable, and but special attention has to be paid to the roof design because of the heavy storage tank. Next objective was all on storage tanks and solar collectors. So most solar water heaters require a well insulated storage tank. So a solar storage tanks has an additional outlet and inlet which is connected to and from the collector. In two tank systems, if we have a two tank system, the solar water will preheat the water before it will enter the conventional water heater. But if we have a one tank system, then the backup heater is combined with the solar storage in one tank itself. So there are three types of solar collectors which are used for residential applications. The first one is called as flat plate collector. The second one is called as integral collector storage systems, and the third one is called as evacuated tube solar collectors. So now talking about the flat plate collector, the flat plate collectors are nothing but they are insulated. They are also weatherproofed boxes that contain a dark absorber plate under one or more glass or plastic polymer covers, but the unglazed collector will typically used for solar pool heating. They have a dark absorber plate made of metal or polymer without a cover or enclosure. In integral collector storage systems, they feature one or more black tanks or tubes, and the cold water will first pass through the solar collector, which will preheat your water. Then that water will then continue on to the conventional backup water heater, providing a reliable source of hot water. And they should be installed only in mild freeze climates because the outdoor pipes could freeze in severe cold weather. The third one is the evacuated tube solar collectors. They contain a glass outer tube and metal absorber tube attached to a fin. The fin's coating absorbs the solar energy but inhibits the radiative heat losses. These collectors are used more frequently for the United States commercial applications. So solar water heating systems always require a backup system for cloudy days and times of increased demand. They usually provide backup and may already be part of the solar system package. And since an integral collector storage system already stores hot water in addition to collecting solar heat, it may be packaged with a tankless or demand type water heater for backup. Now, the next is on how do you select a solar water heater. So before you purchase and install a solar water heated system into your house, you want to check the following. So number one, you will have to estimate the cost and energy efficiency of the system that you're going to buy, which is the solar water heating system. Then you have to evaluate your site's solar resource as to if your house or if your location is very suitable to is having the sun's energy. So determine the correct system size, investigate the local codes, covenants, and regulations. So also you need to understand the various components needed for solar water heating systems, like heat exchangers for the solar water heating system and heat transfer fluids for solar water heating systems. So installing and maintaining the system. So the proper installation of solar water heaters depends on several factors the climate, local building code requirements, solar resource as to if your house is very much near to your solar availability, etc. So therefore, it is very best to have a qualified solar thermal system contractor to install your water heater. So after installation, the properly we have to maintain our system in order to make sure that it runs smoothly. So passive systems will not require much maintenance because it is not having any pump, etc. parts. And for active systems, the maintenance requirements has to be discussed with your engineer, with your system provider, and you have to consult the systems owner's manual, etc. So regular maintenance on simple systems can be as infrequent as every 3 to 5 years. Systems with electrical components will usually require a replacement also, partly or two after 10 years. So these are some of the installation and maintaining ideas of the solar water heater. So the last objective of today's lecture was all on types of heat exchangers. So the solar water heating systems we will use heat exchangers to transfer the solar energy absorbed in the solar collector to the liquid or air used to heat the water or space. So heat exchangers could be made up of steel, copper, bronze, stainless steel, aluminum, or cast iron. So solar heating system usually use copper because it is good thermal conductor and has greater resistance to corrosion. Now talking about the types of heat exchangers, we have three types of heat exchangers. One is called as a liquid to liquid. A liquid to liquid heat exchanger will use a heat transfer fluid that will be circulated through the solar collector. Then it will absorb the heat and it will then flows through a heat exchanger to transfer its heat to water in a storage tank. So heat transfer fluid such as antifreeze protect the solar collector from freezing in cold weather. Now coming to the air, a single wall heat exchanger is a pipe or a tube surrounded by a fluid. Either the fluid passing through the tubing or the fluid will surround the tubing can be the heat transfer fluid, while the other fluid is a potable water. Now talking about air to liquid systems, where solar heating systems with air heater collectors, they usually do not need a heat exchanger between the solar collector and the air distribution system, because those systems with air heater collectors that heat water may use air to liquid heat exchangers, which are similar to your liquid to air heat exchangers. So, solar water heating systems use heat exchangers to transfer your solar energy absorbed in solar collectors to the liquid or air used to heat the water or a space, and they may be made up of any material like steel, copper, bronze, stainless steel, etc. They generally use copper because it is a good thermal conductor and it has greater resistance to corrosion. And while we are designing any heat exchanger, we should have a very clear heat exchanger design, which may be coil in tank type or shell and tube type or tube in tube type. There are three types of designs available. One is called as coil in tank, second one is shell and tube, third one is tube in tube. So these are the three uh, uh, designs of the heat exchangers available. So these are some of the references from where you can have more insight on this topic. Questions for practice include: identify the limitations in solar water heaters, highlight the design of heat exchangers for solar water heaters. So thank you for your time and interest.